In my previous video about radiation detection, I've shown you what happens if you're using a Geiger Miller tube, like that was a strontium-90 with a beta emitter that has just 0.1 microcurie activity versus 0.25 microcurie of cesium. We get a much higher activity, much higher counts per minute from the strontium-90, and that is because it's a beta emitter, and basically 100% of the beta particles interact with the gas in the Geiger Miller tube, or pancake probe in this case, same design anyway. And the cesium-137 is a beta and gamma emitter, so the gamma rays only get detected up to 1%, because the gamma rays will have to interact with the anode material and free electrons, which are again registered by the Geiger Miller tube. So only a fraction of the real amount of radiation is detected. Well, and now I've got a new toy. This is a scintillation detector. It's a sodium iodide thallium detector. And let's see what kind of reading this probe will produce. First of all, let's just turn on the meter and see what happens. Oh, we're mixing out that scale. And as you can see, we have over 1,000 counts per minute of just background radiation. So it's apparently incredibly sensitive. Let's see what happens if we bring the cesium-137 close. I'm not even close, but you can hear it. We're maxing out that scale, switching to times 100, holding the cesium on the probe again. You can see we have about 2,000 counts. So that's quite a lot of radiation from the cesium. Let's see what the strontium does. We'll just leave it on times 10 scale for that. So we can see we have like 1,000 to 1,500 counts per minute of background radiation. Now the strontium-90. Well, that doesn't do much, does it? Just slightly over 1,500. That's because this type of detector cannot register anything but gamma and X radiation. So I'm just using the pancake probe again with the aluminum shield in place, because well, that sodium iodide scintillation counter is shielded as well. So let's see what happens if we bring up a really tiny amount of thorium ore. Okay, switch it back to times 1. And there's not really a lot happening, as you can see. Now let's try the scintillation counter. Again, about 1,000 to 1,500 counts background. I'm going to bring the thorium closer. I can already measure it. And you can see it produces a notable reading of about 2,800 counts per minute versus just 1,000 counts background radiation. Well, that probe is incredibly sensitive. Now, just for fun, I'm bringing the radium close. I'm holding it in my hand with my arm stretched out, but it already begins to register, so just bringing it a little closer, see what happens. And you can see it already begins to register. Switching to times 100, and let's see again. You can see we already have about 20,000 counts per minute. If I put that on top, we're totally maxing out the meter. Now here's an incredibly tiny amount of radium. Now you can see the tiny white flake on the top of pliers there, because the scintillation counter has a hole in the front where you can insert small samples that will be surrounded by the scintillation crystal. So let's see what happens if I insert this absolutely tiny flake of radium in there. We're on the times 100 setting. You can see we're getting about 10,000 counts per minute from this tiny little piece of radium paint. Now let's see what happens if I put my tiny piece of trinitite in there. I'll just insert it here. Now you can see we're getting over 2,000 counts per minute. Now here's a small flake of uranium ore. Now here's a small piece of chloride, another uranium ore. Well, we're maxing out the scan here. So, to sum it up, the sodium iodide scintillation crystal is really awesome at detecting gamma radiation. It is incredibly sensitive and detects radiation from a long distance. Well, the disadvantage is that this type of crystal will not be able to detect any alpha radiation, which is kind of obvious because of the aluminum around it, but it will also not be possible to detect any beta radiation. So it solely detects gamma and X radiation. And the sensitivity on the wavelength, so on the energy of the radiation, also depends on the voltage set in the device. But as I cannot set my CDV to any other voltage than the standard operating voltage of around 900 volts, I'm gonna have to explain more on that later.